All right, so let's try 3C first. Okay, I'll give you a couple minutes and then I'll draw the diagram for it. So on this one, we've got 8 meters east and 6 meters at 35 degrees north of east. So there would be my 8 meters east, north of east. So I draw my reference line due east. I go 35 degrees north of it. For 6 meters. Okay, so I think I've roughly reflected the scale given to me in the question, and that would mean my resultant goes here. And I can draw that triangle for the resultant this way, okay? Or I can draw it this way. I think given the answer I see there, I probably drew it up this way, just so that my resultant's triangle wasn't overlapping all my other lines. Yeah, so guys, the other correct answer you could have here is 15 degrees north of east, okay? Still be 13.4 meters, but your other vector that would also be acceptable would be 15 degrees north of east. If you drew the triangle over top of your other stuff, that's the angle you'll get. Okay, it's fine, it's complementary. Okay, so our next few steps here, we got to find all of our x's and all of our y's. So black x will be the cos of 35 times 6. Y will be the sine of 35 times 6, because x is adjacent and y is opposite. Okay, so I'm getting 4.91 meters east for black x. Uh, 3.44 for y north. Okay, and then from there I can get my resultant's triangle. Okay, I can get green x, okay, by adding the two x's together, so that'll be 8 plus 4.91, so that'll be 12.91 meters east. And obviously I'll have all my decimals in when I do any math with that. Okay, and y, well, black y and green y are equal, okay, so that's going to be 3.44 meters north. Okay, what do I do after that? Oh, okay, well, if I add them, this is this side and this side. I have to add them, but I have to do something else too. Because I'm trying to find this.
Oh, square them and take the square root.
Right, use Pythagorean theorem. Square them and take the square root. Okay, so to get d, okay, that's going to be basically x squared plus y squared square rooted. So we'll have our 12.91 squared plus our 3.44 squared. Whoops. I'll just punch in 91492266 squared plus that number squared. Okay, so I've got 13.37. And that's going to be meters. I don't know which direction that is yet because I have to calculate that still. Okay, and to do that, I'll just use tan. So theta will be 10 to the minus 1 of opposite 3.44, because that's the way I drew the triangle, divided by the, nope, it isn't the way I did the triangle. I did the triangle the other way. So it'll be 12.91 divided by 3.44. Okay, and that will give me my 75 degrees, and that will be east of north. But if you did it the other way, you got 15 degrees north of east. Okay? How many significant digits should my answer have for that question?
3.
How many does this one have?
2.
2? Okay, and I always go with my
Smallest.
smallest one. Yeah. Okay, so everything in that question. So is my answer correct?
No.
Nope. Should be just 13. Yep. Okay. Everybody all right with that one? Take it.
Wouldn't it be north of east?
Nope.
75 degrees north of east, because you're going, yeah.
I'm going
But
east of north. The 15 degrees, this angle is north of east. Okay, your second direction is always the compass direction that the arc touches. This one's touching north and going east, rotating east of north.
Oh, yeah, because
Okay.
if you did 75 degrees north of east, it'd be a little bit.
Would it be like there? Yeah. Does that make sense?
Yeah,
Okay.
okay.
All right, I want you guys to try D. Okay, now D, scale is important. Okay, people mess up the diagram on this one a lot. We can. Okay, let's look at the diagram for this one, because I always put this one on just because it does this to people and makes them think about what am I doing with my diagram, what do these angles look like and things like that. So this part's easy. I got 12-meter long due south line. Okay, this is the part that messes with people. The next vector is 55 degrees east of north. Is that more than halfway to east? Yeah, 45 degrees is halfway. Okay, so I'm looking at an angle. Here's my reference line. Okay, that's got to go like this. Okay, now here's the other mistake people make. They're like, oh, well, this line's longer than that one, so hey, look, it makes a right angle triangle. You're not that lucky. Okay, you're just not. That's not ever going to happen, okay, for you. I'm sorry about that. Sorry about your luck, but no, that's just not going to happen. Okay, so even if I draw this line to scale, and I make it longer than my 12-meter line, which it is, it's probably decently done that way. Okay, this is what I'd be looking at. Okay, remember it's only 3 meters longer than the 12-meter line, and it's angled more than halfway down.
Oh, actually, I did that.
Okay, so it's got, I think that angle might even be a tad bit shallow. It should maybe even be a little bit further, but we'll leave it. Okay, just because it's approximately what that diagram should look like. Very often I have people draw this and it ends up above, ends up here, and I'm like, remember this thing is only 3 meters longer than that first line. It's not going to go that far.
I drew my triangle above it. Like I made a box.
Oh yeah, yeah, you could totally draw it here as well. Yeah, your resultants triangle, I haven't drawn that yet, so, okay. I haven't drawn the resultant in yet. So this would be my resultant right here. Okay, so that would be my resultants vector. This would be my resultant displacement, resultants x, resultants y. Okay, I'll give you a few more minutes to work on that before I do the rest. Okay, so let's walk through this one here. Okay, I've obviously got to get my vector components first, so that would be black x and black y. Okay, so black x is going to be the sine of 55 degrees times 15. All right, so that's 12.29. And that'll be east. Okay, and y is going to be cos of 55 times 15. 55. All right, so we got 8.60 for that one, and that's going to be north. Okay, and then we also have our x and y for the 12-meter line. Okay, x for the 12-meter line is 0 because it doesn't go east or south, and the y is 12 meters south. Okay, and I always put those in just so that I keep them straight. All right, so now I've got my numbers. Now I can find my resultants x and y. Okay, so my resultants x is just going to be the 12.29 because that's the only time I ever went east or west. Okay, so that one I don't have to do any extra math for. All right, then I've got to get my resultants y, which is going to be the 12 meters south minus the 8.6 meters north. Okay, so I'm going to end up with 3.40, excuse me, meters south. Okay, so now I've got green x, 12.29 meters, and I've got y, 3.40 meters, okay, in a south direction. So those are my two vectors. Now, what I'm seeing happen here on a few people's papers, and this is something that often happens, is people calculating the wrong angle. Okay, I see sometimes people will calculate this angle right here. Right? The reason we don't want to do that is that angle points from my final position back to my initial position. That's telling them how to get back. This question is about how to get from initial to final. So if you're ever confused as to which angle do I find, I always tell people, circle your initial position. Wherever that circle goes through your triangle, that's the angle you want to find. That's your arc right there. Okay? So I'm looking for the one that is going to be south of east. So now that I've got that, now I can find my overall displacement with Pythagorean theorem, same as we always do. So 12.29 squared plus 3.4 squared. Okay, and that's going to give me my 13 meters. Okay, and then I'm going to find my angle here, okay, which will be the 15-degree one, not the 75, because I drew it above. Okay, so that's going to be 10 to the minus 1, so theta will equal 10 to the minus 1 of 3.4, my opposite side, over 12.29. That'll give me the 15 degrees south of east. Okay, but 75 degrees east of south is also acceptable as an answer. Okay, all right, is scale important? Yes. Most people don't get the lengths messed up with scale. It's usually the angles that get messed up with scale. Okay, that 55-degree angle in this question is a prime example, right? Most people don't draw that far enough down, and then they mess up the diagram because of that. Okay, all right, let's take like a 4-minute break here till 10:10, and then we'll try E. Is the diagram tricky for this one?
Yeah.
Super tricky. Okay, this is probably about as tough as the diagram gets. It really illustrates the importance of scale. Okay, so my first one is 5 meters, 26 degrees south of east, and my other one is west of north. So I'm actually going to start down here so I've got room for it. Okay, I'm going to draw a line that's due east. I'm going to go 26 degrees south of that. Say that that's 5.0 meters. There's x, there's y. Now, my next line is 58 degrees west of north. So I've got to draw a reference line that's north, and then I've got to go 58 degrees west of that. So it's almost backtracking completely, almost, okay, not quite. Okay, and I've got to make sure, whoa, that line's crooked. Okay, and I've got to make sure that it's longer than my 5 meter line. Okay, so something like that probably. Okay, I think that line's probably not quite long enough just because I ran out of room over here. Okay, I didn't give myself quite enough room. So this here will be 58 degrees. It's not really, it probably should have been lower. Okay, in fact, you know what? I'm just going to do it again just because I don't like how it looks. And this diagram is supposed to be super accurate, so I'll just give myself more room. Okay, that's better. Okay, the other part of this diagram is it goes right over itself completely. Okay, I've got to draw lines over other lines and numbers that I put in there, so it gets kind of messy. Okay, and that means then that my resultant goes from here to there. Okay, so that's what your diagram for that one should look like. Okay, it's tricky, and scale is really, really important. Okay, so on this one here, guys, if we're looking to get all of our bits and pieces, okay, our x component for our first 5 meter vector, okay, that's going to be the cos of 26 times 5 meters, okay, and for our y, it's going to be the sine of 26 times 5 meters. Okay, so 4.49 meters east, okay, and then sine of 26 times 5, okay, is 2.19 south. Okay, got to do the same thing for the black triangle. Okay, so x is going to be the sine of 58 degrees times 7. And y will be the cos of 58 times 7. And so 5.94 meters west, and okay, 3.71 meters north. Okay, so now that I've got those numbers, okay, they're all opposite. My x components are east and west, and my y components are north and south. So rather than add them, I'm going to subtract them when I get my resultants x and y. Okay, so my resultants x, okay, is going to be, like strictly speaking, it's going to be 4.49 meters east plus the 5.94 meters west, but it's really going to be this. Okay, and I'm going to get like negative, what, 1 point something. Okay, so 4.49 minus 5.94, okay, is going to give me 1.45 meters west. Okay, and when I do that for y, okay, I'm going to take my my north, which is bigger, minus my south. Okay, so 3.71 minus 2.19. I should have done that with the other one, but I was being too fast. Oh. Okay, so 1.52 for that one, and that'll be north. Okay, so now I've got the two sides of my resultants triangle. They look about right, and they're really close to the same, which would be why I get 43 degrees. okay, the two sides of the triangle are almost equal. When they're equal, I get a 45-degree angle. So those answers, those numbers make sense kind of going forward. Okay, so we've got about 2 minutes left in class here. I just want to talk about what's going to happen next week. So on Monday, we're going to talk about significant digits, because we still haven't done it. We're getting to do it. Okay, so we're going to talk about significant digits on Monday. Do a bit of, we'll start the math activity with vectors. That'll take us 2 classes. But then we'll do kind of some more vector stuff, talk about both questions. We probably won't get to graphing until late next week. Okay, that's kind of where we're sitting today for right now. All right, if you're struggling with this stuff, make sure you pop in to see me either during my help times or in that little bit of time that you guys get to vote on the name for. Okay, after period 3, okay, any of those times is acceptable.
Are we doing the last entry this year?
We are not. We no longer do it because they kept ripping us off and we're tired of it. Customer's always right, and they don't believe that, so they're wrong. And they're right. Yeah, they're not getting any more of our money. Every time we sent them money, like, well, the price went up. Like double. 2 years in a row, like double price up. No longer economically viable. Can't be asking kids to pay $120 to go to West Edmonton. All right. There we go. Okay. So have a good weekend, you guys, and we'll see you on Monday.